Hi guys, I'm going to go through your solubility rules examples with you. So things to note when we do solubility rules. We do have a set of rules we can go through, but there's a few tips and tricks that can make it a lot easier. First off, if you have a group 1 metal, you can assume it's aqueous. That means you're going to put the AQ designation with it. If you have a nitrate or an acetate, we can assume it's aqueous. Everything beyond that, we're probably going to need to look at our rules. And this is referring to ionic compounds. Now, when we get to lone elements, there's a little bit different things that happen. If it's a lone metal by itself, it's usually going to be solid. Diatomics are usually liquids, gases, except for bromine, that's a liquid. Covalent compounds are going to generally be gases, except for water, which is generally a liquid. So we're going to go through and do some examples. We'll do some where we write out the problems. We'll do some where we predict the problems. But first, let's just go through and do these. So the first one says, I have lead 2 nitrate. I just got done telling you that nitrates are generally aqueous. Reacts with potassium iodide. Potassium is a group 1 metal, so that's going to be aqueous. Now this one I'm going to skip because potassium iodide, I don't know off the top of my head, but I do see a group 1 metal with a nitrate, so we know that one's also aqueous. Now the rule for potassium iodide is the rule that says all binary compounds, so compounds with 2 elements, a metal and a nonmetal, of group 17 elements, so anything bonded with a halogen, iodine's a halogen, are soluble, which means they're aqueous, unless they're with silver, mercury, or lead. Well, this is lead 2 iodide, so this one's going to be a solid. Non-double replacements, a lot of the time what you have is 2 aqueous compounds combined to produce a solid that's in an aqueous solution. So the next one, I have iron 3 chloride. If I go back to that rule I just went over with you, it says all binary compounds of group 17 elements with metals are soluble except for silver, mercury, and lead. Well, this is iron, so we can say this is aqueous. Sodium is a group 1 metal, aqueous. Sodium is a group 1 metal, aqueous. Now, what's the rule for hydroxides? It says, except for those in Rule 1, and Rule 1 said, all common salts of group 1 elements and ammonia are soluble. Carbonates, hydroxides, oxides, sulfides, and phosphates are insoluble. So because this hydroxide here is with something that's not a group 1 element or ammonia, it's solid. All right, on the third one, I have a lone element. So this lone sodium is going to be a solid. Water is generally a liquid unless the word problem says otherwise. Sodium hydroxide, that's a group 1 metal, that's aqueous. And H2, this is hydrogen, we're going to say it's a gas because it's a diatomic. All right, let's scroll down to the next ones now. All right, this one we're going to have to actually write out the problem, and then we're going to figure out our phase notations. So it says potassium chlorate, when heated, yields potassium chloride and oxygen gas. So potassium chloride. Potassium is K. It's in group 1, so it's K+. Chlorate is ClO3 with a 1 minus. So if I crisscross that, my formula for potassium chlorate is KClO3. When heated, yields potassium chloride, K+, Cl-, KCl, and oxygen gas. Well, it already told me oxygen is going to be a gas. That's a diatomic. So these are both group 1 metals. That means these are both going to be aqueous then. So when this decomposes, you're going to end up with this soluble solution and then some gas that we're going to lose in an experiment. All right, and then let's do our last one. In our last one, we have to predict the products. It says potassium phosphate reacts with aluminum nitrate. Potassium phosphate. So potassium is K. It's got a +1. Phosphate is PO4 minus 3. So K3PO4 reacts. So reacts with is a plus sign. Aluminum nitrate. Aluminum is +3. Nitrate is -1. I'm putting this in parentheses. Oh, sorry, that's a 3. Because this is a polyatomic ion. So it's going to react. So we're going to trade some partners here. So the double replacement. So these two guys are going to trade partners. So we're going to get potassium with nitrate. And I'm going to rewrite this all at the bottom, and then we will do the phase notations. And then we're going to get aluminum. Oh, +3, -3, those are going to cancel as well. So potassium nitrate plus aluminum phosphate. So let me just rewrite this whole thing. Do I have space? Did I leave myself space? Oh, I didn't. Okay. Well, we're going to pretend I did. Actually, I have room to fit over here. Where's my purple? There we go. Oh, that's red. Purple? Can I have purple? It doesn't want to give me purple. Oh, well. This is fine. All right. So I have K. Oh, does not look like a K. So KNO3 plus AlPO4. All right, so let's come up with our phases on these. And I'm going to do this in this lovely blue color. So group 1 metal, aqueous. With a nitrate, aqueous. With a nitrate, aqueous. Aluminum phosphate. What's the rule on phosphates? Phosphates say if they're not with a group 1 metal or ammonia, it's going to be a solid. So those are your examples for solubility rules. I hope this video helped you out. Send me a message if you need extra help. I'll talk to you guys later. Bye.